This is a fast process. We're going to move a lot of fish.
As they fight their way upriver to spawn, river herring get some help from volunteers.
These fish have traveled thousands of miles, and now to have one dam stand in their way, people are not going to allow that to happen.
Building a new industry on biofuels. Why these startups say they need help from Washington.
Did you ever think you would be a moonshiner, Louise?
No.
With help from Mother Nature, with an island as their classroom, these students learn how to keep their water clean.
Every single person can make a difference.
And another idea to purify water, a secret inside a prickly plant.
I couldn't believe it. I was like,
So stick around. This American Land starts now. Funding for This American Land provided by the Weiss Foundation, the Pew Charitable Trusts, and the Turner Foundation.
Hello and welcome to This American Land. I'm Bruce Burkhart.
And I'm Caroline Ravel with some really special stories for you today about America's natural resources, our landscapes, waters, and wildlife, and about people who are dedicated to conserving those resources. We'll start on the Saugatucket River in Rhode Island, where every spring tens of thousands of river herring try to swim upriver from the Atlantic to spawn, facing dams on the river that block their way. Many fish find it too exhausting to use the fish ladders on the dams, and they give up their struggle. But happily, there are people who volunteer to help the fish on their journey in an effort called a fish lift to get the herring over the dams. We sent our crew to the river to see them in action.
Right now, I'm standing in front of the Plimco Dam. This is the last dam on this small brook system leading up to a 269-acre river herring spawning habitat. My name is Eric Hutchins. I'm with the National Marine Fisheries Service. These fish live at sea for 3 to 4 years until they're old enough to spawn. They return to the river systems, and in they come in waves into the spawning habitat. River herring, unlike salmon, seldom ever break the surface of the water. They need to stay in the water column. They can go up steep stuff, up to sometimes 18 inches, and do some fast water, but they don't jump. And if you've got a place that's got too much turbulence, that's an impediment. That can hold them back. And certainly right here, there's no chance for them to make it up through this.
Every river in the Atlantic coast is littered with these abandoned industrial age dams. I am Peter Shelley. I'm senior counsel with the Conservation Law Foundation. At the time, they made a lot of sense. You know, those dams were responsible for the birth of this country in a lot of ways. Their function is no longer necessary. It is the highest priority for river herring, getting rid of these dams, just removing them.
Oh, there's another over here.
So what we're going to do today is we're going to put a net in here and bucket some of them around and give these guys a free ride.
You know, one of the big challenges is we're spending hundreds of millions of federal dollars, as well as millions of hours of volunteer effort restoring these herring runs. But these fish go back out to sea, and they're subject to being caught in the sea herring fishery, and a lot of these efforts are wasted.
Look at all these. This is a mega load. Virtually every place where dams have been removed, the numbers of river herring multiply. I'm John Bullard. I'm the Regional Administrator for the Greater Atlantic Fisheries Office of NOAA Fisheries. But we have to solve the problem at sea as well. We need to know how many are out there to base the limits or quotas on how much can be caught. And then you need to be able to enforce or observe how much they are catching. We are pushing all three of these as hard as we can. Basically, my job is how do you have both fish and fishermen? Working waterfronts are really special. We send our people to sea. We've always sent our people to sea with a purpose. Fishing's a purpose.
For someone who owns a fishing boat, their time scale is this week, maybe next week, but certainly by the next mortgage payment, which means they got to catch fish. But the health of the fishery depends on a longer time scale. Because of mismanagement, because of a failure, really, by the federal government and the fishery managers, many of whom are fishermen, we have had decades of overharvesting. And we have built a fleet that is many times bigger and more powerful than the ability of Mother Nature to sustainably produce fish.
Everyone wants to see jobs created, and everyone wants to see a healthy resource. Fishery management is incredibly complex.
The art and the science of passing fish on the East Coast is fairly new. I'm Bill McGraw. I'm the coordinator for the herring lift on the Saugatucket River in Wakefield, Rhode Island. A fish ladder is just a graduated passageway with barriers to try to slow the water, and also those barriers will give the fish a place to rest behind sometimes. It was built for Atlantic salmon. These herring do not have the same drive, so when the rivers are full like they are this year with a lot of rain and the velocities are high, these herring cannot go up it. It's just too much water for them. This is a fast process. We're going to move a lot of fish. Boom, boom, boom. These fish have traveled thousands of miles. They've been at sea for 3 years. They have avoided every possible danger, net, predator. They've made it back to their natal river, the place where they were born. And now to have one dam or two dams stand in their way, people are not going to allow that to happen.
It's been a frustrating battle. We've been working for many years to try and rein in this industrial fleet of ships. My name's Peter Baker. I work for the Pew Charitable Trust, and I'm a founder and director of the Herring Alliance. So a lot of what the Herring Alliance's work to do is make sure we have federal monitors on those boats to be able to sample what they're bringing aboard, to be able to quantify what they're killing. Unfortunately, to date, National Marine Fisheries Service hasn't actually ponied up the funds and gotten the humans on every trip. So years of work has been stymied.
I'd like to see us solve the observer issue, where the industry is paying 100% of the cost of observers at sea.
I think everybody really just wants to help these guys out. They're just stuck here and they have nowhere to go.
That was 3,520 fish in about 35 minutes.
It's really gratifying to come out today and to see as many river herring sitting in this river as we see. But to really bring the fish back in the numbers that they once were, or to even get close, we have to really understand, monitor, and limit the amount of river herring they're getting killed by the industrial trawl fleet.
These are difficult problems, and they're problems that we can make progress on. And they've languished for a long time. We're tackling it here, and you're tackling it with us out at sea, and we're going to keep holding your feet to the fire.
We have another story now on second-generation biofuels, the new frontier in renewable sources of energy, sources grown as agricultural crops. We'll take a look at the challenges faced by new biofuel enterprises that are still in the startup stage, trying to develop their technologies, scale up their production, and secure a market for their products with some controversial government support. We'll start in eastern Tennessee.
This is a raid on a moonshine still operating in the southern part of the United States.
In eastern Tennessee, they are at it again. Did you ever think you would be a moonshiner, Luis?
No.
Stamping out such illegal activity is difficult and dangerous work.
But nowadays, the feds are encouraging this activity with a 2007 law, the Renewable Fuel Standard, which mandates a certain amount of the nation's fuel supply comes from renewable sources, like ethanol.
We extract the sugars from a cellulose, and then once the sugars are out, we ferment the material. Once the material is fermented and in solution with water, we move it into the distillation area.
People in East Tennessee say they've been making ethanol for a long time up in the hills, and essentially we're doing a similar type of process.
Steve Mershak is with a very old company, DuPont, helping to develop a very new industry, cellulosic ethanol, liquid fuel made from plants containing cellulose, which in turn contain the sugars necessary to produce ethanol. And this demonstration plant in Vonore, Tennessee is helping to pave the way.
The mission of Vonore is to demonstrate the technology required to convert corn stover and switchgrass into ethanol, and to generate the basic data that we need to design and engineer a full-scale commercial facility.
And that commercial plant will soon be a reality in Nevada, Iowa, where DuPont is building a facility to turn out 30 million gallons of cellulosic ethanol a year, compared to only 250,000 here at the pilot plant in Tennessee.
This is feedstock that we use to run the process. This one, I believe, is switchgrass.
Though corn ethanol production has been around for several decades, this next generation of cellulosic renewable crops like switchgrass or corn stover is in its infancy, and the industry is just learning to walk, developing the infrastructure and the supply chain from farm to the gas pump.
Just for perspective, I think it's important to keep in mind that we have had 100 years or more to develop the oil-based fuel infrastructure that we have today. And this whole cellulosic biofuels industry, the R&D started a couple of decades ago, but the real thrust has only been the last few years.
Kelly Tiller and her company, Genera Energy, have partnered with DuPont to create a model for future cellulosic ethanol operations. Genera's role is working with nearby farmers to figure out the best systems for growing, harvesting, transporting, and storing the material. Like most things, the devil is in the details.
We do a lot of work here focusing on how to best store, what are the best practices, what factors influence that quality, how do we manage moisture over time.
Do I put it on gravel? Do I put it on dirt? If I put it on soil, then does it wick up and wreck my bottom row? If I put it on rock, do I avoid that? All those questions have to be answered.
About 900 miles from Vonore, Tennessee, Andy Suby at Iowa State University is trying to answer the same kinds of questions. But in this part of the country, the primary biomass is corn stover, the leftover stalks and cobs left in the field after corn is harvested.
Can you ever think of a time that's more exciting to be in agriculture? Because we're on the edge. I mean, this is a chemical revolution that's coming, and we're right on the edge.
And like the petrochemical industry, fuel is not the only product that can be created. It's just that these products are coming from a cleaner and renewable resource.
It's not just about the fuel. It is about fuel, but it's about the chemicals too. This is what you make with biomass feedstock. This is fuels, this is chemicals and other products, value-added products. And so be in the market that you need to be in at the profit that makes the most sense.
If this fledgling industry is to grow up and fulfill its promise of energy independence, it says it needs the policy stability of the Renewable Fuel Standard, a hotly debated topic in Washington these days.
Just like oil and everything else, oil gets a subsidy through tax credits and things like that. But if you want to grow an industry that is baby industry and it's not profitable within 2-year ROI, you got to bump it a little bit, right? But then the whole point is to get it to that profitability so private industry can take it and go. And that's the whole idea behind it.
Corn stover here in the Midwest, down south maybe it's switchgrass, and in the Northwest perhaps wood waste would work best. But cellulose is the most abundant organic material on Earth, and it's renewable and clean. And though cellulosic ethanol doesn't have to worry about the IRS, there are the challenging economic and political realities of building a complex industry from scratch.
Living on an island may sound exotic and exciting, but for people living in the San Juan Islands off the coast of Washington, it also means being conscious about protecting the land, water, and wildlife. An island can also be an incredible classroom. With some help from the Captain Planet Foundation, high school students on Orcas Island are keeping their water clean, thanks to some simple tools from Mother Nature.
One of the things that's neat about teaching here in this very rural community on this little tiny island is that we kind of get that we're part of the environment. You're driving on roads that are right next to the ocean, and you can pretty clearly see that we are interrelated with the things that grow in the ocean. My name is Marta Branch, and I teach at the Orcas High School. My background is in environmental education. I'm a science nerd.
It's when a glacial valley fills up with salt water, that's a fjord. It's that geologic feature, okay? And East Sound is one of them.
There's so much stuff to talk about. She comes back every year and stays in this spot, but leaves in the winter. We call her Bertha because we've gotten to know her, and every year she's a little bit bigger. All this diversity is here. Invertebrates, fish, seabirds, a few hundred yards from what is actually the biggest town in our county. And the fact that it survived is extraordinary.
This particular ecosystem that you see behind me is surrounding this little island that we have out in the bay. This is Fishing Bay, and the island is called Indian Island. And because we are right next to a dense human population, the village of East Sound here, and we also have the surface runoff from the roads, we're concerned about the water quality of the watershed and how it's affecting this area.
We studied bioswales, which is a way to filtrate water going into storm drains so that bad pollutants don't go into the ocean. We wanted to create a bioswale right here to filter out all the water that goes through down this parking lot.
Remember the sort of three main components of the rain garden. You had plumbing, you had soil, and you had plants. Right? So we're going to try to get the plumbing done together. Sound good? Yeah, sounds good. Yeah. Leave that one there, that one's going to be too short. Wow. There's that.
I wake up every day and I'm really happy to be on Orcas. We went through different kinds of ways we could take out chemicals before they got into our water.
And that's really what we've been learning about. Just plants and things like this are really the best filters for water runoff in general.
So I want the top to come up maybe 2 inches over the pipe.
We did a lot of sample testing, and we looked at the areas where the water runs into, and we were going over plants that would be easy to grow, like easy to find, that are native to our island. And so we thought mushrooms because they are easy to grow, easy to find, and they filter really well.
We start with live mushrooms, and I get to clone them. This is the fun part. I get to do some lab work. And then it goes on to pasteurized straw, which is what we have here. It has kind of an interesting smell. You can sort of see they've started to colonize. There's white mycelium in the straw. The students in Marta's class actually tested oyster mushrooms from Orcas to demonstrate that they can break down motor oils. So while motor oil isn't necessarily the contaminant we expect coming off the roof, that suggests that they have the ability to digest a number of different petroleum products.
Filtration is so important because we pollute on the streets and we pollute in the drains, and all that stuff collects in our ocean. It's acidifying our ocean, changing our environments and weathers and temperatures and all kinds of things.
Every single person can make a difference, just whether it's not like pouring your coffee out on the street. It's like being mindful of what goes down the drain is going directly to the ocean.
The fun thing for me working with students is that our job isn't to tell them how things are or tell them what to do, but to give them the opportunities to figure it out for themselves. So certainly they're the scientists in this process, and we just get to support them.
the whole village, the pollutants get dumped right into the beach there, which is some of the most sensitive marine habitat in the islands. And because of the way the village is laid out, there isn't an easy solution.
The standard solution for runoff, build a big facility, hundreds of thousands of dollars or millions of dollars. The kids' answer is, let's garden the landscape.
Let's get some more wood chips in the next couple. Our goal is to show stormwater solutions can beautify, increase property values, and increase the commercial potential of the town itself. I mean, attract more people here. We try to present it as like a win-win situation for everybody and not as like a top-down government kind of solution.
Do things on the cheap, but not without the care that I certainly as a scientist really value. And the best thing about it has been having kids sit and have the patience to work for months trying to figure out whether their designs work.
This project is a great example of the type of project the Captain Planet Foundation likes to fund. Sound citizen science, youth-driven, hands-on, with real environmental outcomes. As adults, we've begun to limit what we believe we can do, but children don't have those limits.
And it was great to have a little bit of help so that we could get started and start demonstrating to the community that kids were on the ball and they were coming up with ideas that were better ideas than our community leadership.
One of the things that I've taught my kids about is the whole idea that, yeah, you can point a finger at a tanker that goes aground and spills oil or whatever, but really there is way more oil and gasoline and hydrocarbon products that are actually coming from the road runoff, and that's everybody, that's all of us.
People are used to things just rolling along, let the county and the state make the decisions. The kids have broken the ice by showing the courage to build something and take responsibility for working at it until they get it right.
What I'm hoping is to create in all of my students an ability to analyze and figure out what their opinion is on a given environmental issue. I want them to understand all the pieces and be able to figure out what are the pieces for the question that's in front of them so that they become an environmentally literate citizenry capable of analyzing and voting on these things that we have before us.
Community leaders here are talking about a whole street being redesigned with bioswales and gardens, and they're very clear about the fact that the kids came up with the idea. And now folks are jumping on board and saying, we could do this.
While we're on the subject of cleaning water, our Science Nation report takes us to a lab where researchers are testing how the goo inside a prickly pear cactus, of all things, can be used to purify water contaminated by chemical or oil spills. Miles O'Brien has this story.
The prickly pear cactus salad. It's a delicacy in Mexico, but it seems these cacti have uses beyond the culinary, cleaning up oil spills and purifying water.
You can see how it's really easy to grow.
With support from the National Science Foundation, University of South Florida chemical engineer Norma Alcantar is using the gooey flesh of the cactus, called mucilage, to clean up polluted water. Her interest in green chemistry came from her grandmother, who told her of using cacti to clean river water in rural Mexico as a young woman.
They will take the cactus plant, they will cut it, they will boil it, and they will use the water from that preparation to clean the water.
When Alcantar tested that process in her lab, she was amazed at the results.
I couldn't believe it. I was like, are you serious? It really works? Because I thought I will see an effect, but I didn't think I will see an effect so dramatic.
These bio beads are made of mucilage.
This is the control, the initial concentration of the methyl blue dye versus the one that has been in contact with the beads.
After an oil spill, cactus goo could be an alternative to chemical dispersants like those used in the Deepwater Horizon cleanup.
The same action can be done with a very low concentration and makes it very sustainable and fairly inexpensive.
Alcantar did water quality tests in Haitian refugee camps after the 2010 earthquake, finding high levels of heavy metals and bacteria in the drinking water. While there, she kept an eye out for cacti, and they were everywhere.
This is in a gas station.
Tests back at her lab confirmed that mucilage could successfully clean the polluted water from Haiti, and that's significant. In the future, cacti could be harvested locally to decontaminate drinking water quickly after disaster strikes. Using a natural product to clean water, it's a sharp idea. After all, there's no reason to get stuck on the old way of doing things.
Thanks for watching, and remember, you can catch us anytime on thisamericanland.org. We'd like to hear your comments and your ideas for stories that you think we should cover. We'll see you next time.
For more information about this program, visit thisamericanland.org. Funding for This American Land provided by the Weiss Foundation, the Pew Charitable Trusts, and the Turner Foundation.